Hello, everyone, and welcome to our webinar for today. During this session, we will be discussing about the anatomy of cloud attacks and how they can be prevented, as well as also provide you guys an overview on Checkpoint vSEC and how organizations are leveraging vSEC as a critical security component to their cloud adoption. So for some quick introductions on the team here at Checkpoint, my name is Kaylee Rasmussen, and I'm on the product marketing team here for vSEC. Our speakers for today will be Itai Greenberg, who heads up our cloud security, as well as Dan Wiley, who is our security architect. This is an interactive webinar, so I encourage you all to please ask questions in the Q&A module. We will be answering your questions live at the end, as well as during the webinar as well. This webinar will also be recorded, so if you're interested in watching this again, we'll have a replay as well as the webinar slides available in an email after the webinar, so please look for that. So without further ado, Dan, are you ready to kick this off?
I sure am. Thank you so much, Kaylee. I appreciate it. First of all, thank you everybody for joining today. What we're going to do first is go over a couple of the attacks that we've seen, specifically around cloud infrastructure attacks. And we'll go over a few cases that we've actually worked within the incident response team. Just as a quick introduction to the team and what we do, we handle customers' attacks, malware attacks, hacking attacks, DDoS, extortion, you name it, as long as it has a cyber component. The incident response team at Checkpoint helps our customers deal with these threats. One of our key objectives is to fully understand how the attack lifecycle has evolved and how attacks against a customer have been perpetrated. The idea behind the team is to provide a rapid reaction force that can be called in an instant and to supply the support that customers need. Now, over the last few years, we've been gathering many war stories, and today we're going to talk about 4 of these war stories today. We'll talk about each one here in a second. But the key component to all of these threats is that all of these customers were running cloud infrastructure that they're either managing themselves or in a hosted environment. They are utilizing basic security controls in most cases and are still finding that they're having issues with some of the attacks that are out there. So without further ado, let's start with some of the interesting war stories. So earlier this year, we got a call from a global telco that was trying to understand an attack against some of their web infrastructure. Let me lay the groundwork. This telco had decided that they were going to try the cloud for the first time to host their advertisement campaign for a new phone. And they decided that they would take their images that they had developed internally and adapt them for cloud hosting. So they got their DevOps team, they got everything together to host it within the cloud, and they put it out there. Now, when they deployed it, they had a very simple architecture with a global load balancer in front, some access lists, and they deployed the infrastructure almost identically to how they had it deployed inside of their corporate environment. They did turn on some cool features that were available, for example, things like autoscale. They had some cool accounting and some monitoring, and they added as much of the cool widgets that you can add inside of the cloud into the infrastructure. And they hit go. So they deployed the advertisement campaign. First day, it was a great success. They saw great uptake in the advertisements. They saw the utilization on their servers increase. Everything looked great. The second day, they came back and they noticed that, it looks like the system auto-scaled a little bit and added a couple more servers. Didn't think much of it because, that was pretty normal for the infrastructure to need more resources, and they kept it going the way it was. The third and the fourth day, it doubled in size for each day. And then the DevOps team was starting to really get concerned around why on earth
are we utilizing so much infrastructure to support this advertisement campaign? Something is not right. So at that point, the DevOps team logged into the Linux instances and started looking around to see what they could find. And at first, they couldn't find anything. So another day goes by, and they see that the infrastructure had doubled again in size. At this point, they did call their security team to come and take a look at the servers, and the security team identified an unknown process in the process tree. At that point, the internal security team interfaced with the incident response team at Checkpoint. We reversed that binary and the actual process that was found on the actual server, and we were able to determine very quickly that the process that was inside of the process tree was actually a malicious binary that could mine Bitcoins and perform DDoS attacks. So we started working with the customer in a much more engaged way. We took the image from one of the servers, we reversed engineered it completely, and we were able to determine that when the DevOps team had deployed these web servers, they had forgotten that one of the web admin consoles was actually still exposed. Part of the access list that they had deployed inside of the load balancer basically allowed access globally to the admin interface of the web server. Now, this web server admin interface actually had a vulnerability, and all the attacker had to do was port scan for that vulnerability, buffer overflow the process, inject the new binary, and the system ran it, and away it went. Now, the reason why the system auto-scaled was because every single one of the servers was at 100% CPU, mining Bitcoins, and the network activity was also at a very high utilization because the systems were performing DDoS attacks. Now, this is actually a routine story. We see this happen continuously within web infrastructure, where the controls that they had deployed in their corporate environment don't necessarily follow into the cloud. Specifically, in this case, there were no IPS configurations. And for example, this vulnerability had been known for many years, but wasn't patched. And if you had IPS with the right signatures deployed, none of these attacks would have been successful. Now, this customer learned a very difficult lesson. Their advertisement campaign was actually a big flop because ultimately it cost much more in server resources when they got the $350,000 bill for all the servers that had been spun up, the resources that were used, the bandwidth that was used. And they actually lost money in the actual advertisement campaign that only lasted a few days. And again, the key component here is that they didn't apply the same security controls that were available in their corporate environment into the cloud. And these are one of the critical errors that we find customers make on a routine basis. So this didn't end so well for the telco. They learned some really hard lessons. But the scary thing is this is just one of 3 more stories that we'll go into real quick. The next story is also related to a virtualized environment. We received a phone call from a power company. And this power company said, "Hey, Dan, we have had all of our servers pop up with a message on the screen that basically said, we're holding your servers for ransom if you don't pay us $75,000. We started reverse engineering the attack, and we came to this conclusion. The customer was in a very big hurry to allow a third-party vendor access into their system. And in their haste, they stood up a RDP or remote desktop server. And the server was directly connected to the internet and allowed the RDP port direct access from the internet. And what we found was if you do this, you're really asking for trouble. Because continuously we see port scans against 3389 and folks are looking for open RDP connections. Why? Well, it's a real easy target to do a brute force login attack. And that's exactly what the attacker did. Is the attacker looked for this RDP port, he found it, and then started brute force logging into that RDP server. Within a matter of days, he was able to guess the credentials. In this case, the passwords were let me in 123, and the username was a very easily be guessed username. Now, once the attacker was in, it gets even worse. So again, remember the customer is in a hurry to stand up this RDP server. So they decided they were just going to put it on their ESX server because that's the fastest and easiest way to actually deploy a server is, hey, let's use the ESX infrastructure that we've already paid for, and let's just stand it up. Well, this customer made one critical error by putting it on their ESX server, is that they had no segmentation within their ESX server. So all it took for the attacker to do was to load a very simple program called Minicats, which basically allows you to dump memory and the hashes of credentials. Use those credentials to pass the hash to go to another server, and they were able to stage their ransomware on all the servers within the power company. Now, you would think at this point the power company would have a few options to be able to restore their infrastructure. Number one, they could restore from backup. And the power company decided that to restore from backup was going to take 3 to 5 days to actually fully remediate and rebuild all of those servers. They had backups. They just didn't want to go through the 3 to 5 days of deploying new instances. Well, the other option was to pay the bad guy. And that's ultimately what they did. But they made one huge critical error with paying the bad guy. They paid him and then they assumed he would never come back. Well, they paid him and he came back 4 days later and now held them ransom for $150,000. They never fixed any of the issues. We made all the recommendations in the world, but none of them were listened to. They assumed that they had time. Well, in this case, now they tripled the ransom or doubled the ransom. And at this point, the customer decided that it might be smarter to actually rebuild the infrastructure to ensure that the bad guy actually didn't have a foothold inside the environment. So that meant segmentation, that meant rebuilding the servers, and that meant putting a VPN or additional authentication inside of the RDP session. The critical error they made within the ESX environment was very simple. It was a flat network with no segmentation. They had no way to actually stop the spread laterally, and they had no way of really knowing on any of the servers if there was actually malware installed on any of those endpoints. They weren't even fully sure of how all of those servers are actually communicating out to the internet. So it's a really important lesson to understand that even though you have an ESX server and you think you've got security controls in one direction, that if it's a flat network and you have no segmentation or visibility or control between the segments, you're going to get yourself in trouble in one way or another. So this power company really learned a really bad lesson. Thank goodness they didn't get to the actual critical infrastructure network segments. They were able to stop billing for those days. So a lot of folks got free power for a few days. So on to our next story. One thing we find customers do is they're in such a hurry to get to the cloud that they make a lot of shortcuts and a lot of bad decisions on how to interconnect the cloud back into their corporate infrastructure. This company was a large retailer. They decided that they were going to start deploying small private instances of their infrastructure into a public cloud, and they were rocking and rolling. And one of the things that they needed to have access to was a MySQL server back inside of the corporate infrastructure. So they stood up a whole bunch of web servers in the public side, but they still needed access to database elements back inside of the corporate environment. Now, what the customer did, because they didn't want to stand up a site-to-site VPN, they didn't want to have to deal with all of these controls, was basically just open up firewall rules inside of the corporate environment to allow direct access from the cloud back into the corporate environment over MySQL. Now, what happened was the similar story as the first story I told, is the attacker found a vulnerability on the web infrastructure that was on the public side of the cloud. They were able to break into those servers. They profiled all the connections that were being made on those servers. And they were able to see very quickly that there was a MySQL connection back to the corporate environment. The attacker then just basically used the credentials that were stored inside of the web server and was able to dump the entire database back into the customer's environment. It gets a little worse. Once the attacker had been able to identify that MySQL was exposed, they also saw that SSH was exposed, and they were able to identify the credentials on the web server and were able to log into the database server directly with SSH. And then they moved laterally to other Unix servers within the environment because everything was the same username and password. And Bob's your uncle. So the attacker both had the data of this retailer and then also had the ability to move laterally between these segments. Very simple controls would have prevented some of this activity. One of the things that we would always recommend is a site-to-site VPN between your private and public areas, making sure that there's additional security controls between those segments, making sure that you have IPS inside of your cloud infrastructure to stop the original vulnerability, and then having a unified view into all of that is absolutely vital. One thing we find with our cloud customers is that they decide that the best approach in cloud is maybe use a non-standard vendor, and now you have to try to connect all the dots between all of these different security solutions, and it's a real pain in the rear to understand how the controls actually match to each other, if and what is actually working, and how to gain that visibility across all of those cloud infrastructures. This customer lost tens of thousands of credit card records and had a very public event that they had to deal with. So remember that the cloud is no different than any other web infrastructure, any other server infrastructure. You have to deal with the same things. You just have to start connecting the dots. So the last story we have is one that's all too familiar to a lot of you on the call. We're finding many customers migrate their infrastructure into Microsoft Office 365. That's where we typically find the first utilization of cloud infrastructure. And part of that migration from your legacy Exchange server into Office 365 is how to actually handle authentication. And Microsoft allows you a couple ways to how to authenticate into Office 365, but the most common is by utilizing Active Directory with ADFS. ADFS is basically a bridgehead between your AD infrastructure and Office 365. Now, this is typically a great, easy migration for folks to migrate from Exchange into Office 365. You get to use your same credentials. Everything works pretty seamlessly. And ADFS provides a whole new set of capabilities to allow you to authenticate users utilizing your AD credentials on all of your platform as a service or infrastructure as a service or software as a service services. It really becomes a cool capability to extend your authentication mechanisms. But there's also some issues with this infrastructure. One of them, we received a phone call from a customer that basically said, hey, Dan, it looks like we're being attacked. Can you help us figure out what's going on? And we were able to tell that the following story. So this customer started using Office 365, deployed ADFS and Active Directory, and all of their other IT infrastructure to the cloud. So they literally had no more IT infrastructure back in the corporate office. Everything had been migrated. They'd also wanted to start standing up internal web apps in different cloud providers. So one of the cool things with cloud is that you can go to multiple providers and do, multiple clouds. So that's exactly what they did. They turned up internal web app that was hosted within another cloud and tied it to ADFS login. Now, the attacker basically just scanned the internet like they always do. They were able to find the internal application web service, and they were able to see the logo of the company. And once they had the logo and were able to identify who the customer was, they enumerated all of the email accounts. And that's really straightforward. You can buy either lists on the dark web, or you can go to LinkedIn or multiple sites to be able to get everybody's email address inside of a company. They then loaded every one of those email addresses into a botnet. They directed that botnet to the web server login page and hit go. And basically, they were just trying to brute force login into the site. Now, one of the things that this customer had forgotten to do as they had migrated into ADFS and AD is that they had a very restrictive repeated login failure parameter within AD. So after, I think it was 5 or 10 repeated login failures, the account would actually log out. Well, that's exactly what happened with this brute force login attack botnet, is that they got locked out of every single account inside of AD, every single one. The botnet also used standard names for admin, domain admin and global admin user accounts, and they were also able to lock out those accounts with this brute force login attack. So at this point, this customer is in really deep shit. How do you unlock all of your user accounts? How do you unlock your domain admin, your global domain admin? How do you actually get access to the infrastructure to unlock it? Ultimately, the only choice you have is a keyboard and mouse, which this customer had outsourced to the cloud. So they actually had to work with Microsoft to actually regain control over Active Directory, reset everyone's accounts, and gain access into their infrastructure. And that took hours, many hours to get resolved. So one of our big concerns going forward are these interconnected cloud attacks. This is just the beginning of cloud versus cloud attacks, where your infrastructure and your security controls in one cloud have a direct relationship to the security and the capability of another cloud or application. And we see attackers utilize the deficiencies in one to gain a foothold in another. And this is just one example. We're seeing the same thing across other applications like Salesforce, for example. We're seeing an uptick in attacks against that. Office 365 is always a great place to start for the attacker. And they utilize that as a first step into a much bigger attack vector across a customer's web and cloud infrastructure. Now, the scary thing is, even just this weekend, we saw some things in the news. Specifically, we found, I don't know if you guys saw in the news where the Defense Department had many thousands of Twitter conversations stored in an S3 bucket that had no security controls. We find other customers have other vulnerabilities within the cloud. And this is just going to get worse, right? S3 is a great example of one security control that leads to a much larger issue. But we find that many customers are being hit with ransomware in the cloud, specific directed attacks for infrastructure attacks. And it's not going anywhere. It's just going to get even more interesting. The key thing, though, in all of the attacks that we find that we've handled within the cloud, we find that customers have not deployed enough security and not enough visibility and not enough control to actually be able to defend against the attacks that are occurring against them. This is the critical component that they're missing, is that a consolidated, centralized view around security is missing in their cloud approach. And it's just going to keep happening until they start introducing those security controls. Now, I think I've given you enough doom and gloom around how bad it really is in the security attack vectors against our customers. The thing I'll leave you with is that if you do have cloud infrastructure, it is being attacked right this moment. The question is, how can you actually respond to it? Do you have the controls, the visibilities at layer 7, SSL inspection, all the things that are required to be able to actually see the attacks emerge, and how do you actually respond to them? And with that, I'll let Itai take over the presentation, and he can talk about one approach Checkpoint is using to help you to secure your cloud.
Thank you, Dan. Thank you very much, and hi, everyone. So again, my name is Itai Greenberg, and I'm leading the cloud security in Checkpoint. And I will explain to you how Checkpoint is actually helping customers to deal with securing their cloud. And I will continue from the point where Dan mentioned before, that when we look at vulnerabilities in the clouds, we see that there is a shared responsibilities between what the cloud vendors provide and what you, the customer, is responsible for. Putting your applications in the cloud is not like putting your money in the bank. The bank is liable for your money, but the cloud vendors is not liable for your data and your applications. It's you, Mr. Customer, that is responsible for your application. The cloud vendor says, my compute, my storage, my networking will always be up and running. This is my guarantee. The infrastructure will be intact. But everything on top, the application, the data, this is you, the customer, responsible to secure it. Yet securing the cloud is not something that we can take the legacy security that we had in the data center and apply it in the cloud, because we moved to the cloud because we want to be more agile. We want to do things much faster. And security is perceived as a showstopper, something that prevents the DevOps team to move faster. It's static. It requires to open tickets, a lot of manual operations. And the DevOps team find themselves doing things quite fast on the cloud, but then waiting maybe days or weeks for the security team IT to catch up. So we need security that is function totally different in the cloud. We need security that enables the cloud and not inhabit the cloud. And this is how Checkpoint is looking at things. We have Checkpoint vSEC. This is our solution for the different cloud environments. We provide the best advanced security. And the next few slides, I will talk about the depth of the security that we provide in the cloud, since Checkpoint is providing the best catch rates in the market for threats, for vulnerabilities. But it will also talk about how vSEC was designed to help the organization, specifically the DevOps, to be more agile and to enable the organization to be much faster with deploying applications in the cloud. Checkpoint has a very strong partnership and integration with all those different cloud vendors. On the public cloud, we have Azure, AWS, and Ali Cloud, as well as Google, with our integration and securing those clouds. If customers are building their own private cloud on-premise, we have a very tight integration with VMware, with the NS6 SDN solution, with Cisco ACI solution, as well as with OpenStack and Nuage. And if you go today to Microsoft Azure or AWS, you'll find Checkpoint right in the marketplace homepage. We are the #1 most popular products on AWS and Azure from network perspective, a network security perspective. So we are very, we have a lot of customers that we'll talk later on about how they use and how they consume Checkpoint in the cloud. If we look at the shared responsibility, we mentioned before that the cloud vendors provide the infrastructure security. vSEC, the Checkpoint vSEC on top, would give you the next generation firewall and VPN with all the integration to Active Directory, to LDAP, the ability to understand the application, the integration to the cloud environment, as well as the advanced threat prevention with our SandBlast technology, as well as forensics analysis. So we took everything that was available on a regular appliance, we virtualized it, and it's available on all the clouds. So you have all the security functions, all the security layers available in the cloud. So here I'm showing you that, for example, in Azure, but it's not only in Azure, this is just an example to illustrate. You can run vSEC in this cloud environment to secure your workloads, your applications running there, and you can apply firewall, application control, URL filtering, antivirus, anti-bot, IPS, and threat emulation to secure your application with all those security functions that we have. And this is probably where the R&D invested most of the efforts. vSEC was designed to enable the organization to move fast. So the security is in the speed of the DevOps with a lot of integrations to cloud automation and cloud orchestrations. The first thing is that we have a lot of integrations, plugins with the repository of all the applications in AWS, in Azure, in vCenter, and so on. And we learn from them about changes that happen in the cloud. So when a new application was added to the cloud, All the clouds, Azure, AWS, VMware will tell us about this change. When application change the IP address, when application is growing, when someone added a new VNIC to application or changed the name, any single change that's happening in the environment, we know about it in seconds. And then we know how to adapt our policy accordingly to make sure that the application stays secure even as it's changed, as it evolves. We develop auto-scaling across all the cloud environment. Again, private cloud and public cloud, which means that our security can grow and shrink based on the demand, the application demand. So if we see that we need more security CPU, we will allocate more CPU to handle more loads. If we see that we need less, we will scale down. And the customer pays for only what he consumes. Again, we have what we call the elastic licensing, that with a single license, you can secure all your application across all your clouds and scale up and down as needed. And we developed a lot of provisioning and templates and recipes with our REST API. So first of all, we have a very rich RESTful API that you can use, but you don't need to start from scratch. You can go to, for example, AWS and find a lot of cloud formations that Check Point developed for different use cases. I want to deploy Check Point automatically in a cluster mode, in high availability mode. All those kind of automations are already pre-developed for you guys, and they are accessible for you. So if we look at kind of a high-level hybrid cloud security architecture with vSEC, you see that in the middle, Check Point vSEC is running inside your data center, your virtualized data center, your private cloud, and we have integration with the different SDN vendors, so we can secure east-west traffic inside your private cloud. And if you look on the left side, you see that we have Azure, and we can secure the different VNets and the applications run on the Azure side, as well as on the right side, we secure all the different VPCs in AWS. We have a transit VPC deployment where every time you add a new VPC to the environment, it will be automatically secured by Check Point vSEC in this kind of architecture. And the beauty is that you have a unified management and security policy across all this environment. So with a single rule, you can allow application that runs in Azure to access applications that runs in AWS, even though that the traffic flows through multiple enforcement points, multiple security gateways across the network. But a single rule will allow this connectivity to happen. And we aggregate all the logs from all those environments, and you can see the flow. You see how the traffic flow. You see whether traffic is allowed or blocked, and at which point it goes through. So this gives you a full visibility of your entire environment and consistent control across your security posture. I want to show you a short demo to illustrate one of our adaptive security technology that we have in our systems. So I will start with, in this video, you will see how we are starting in the private cloud with VMware. I will show you how I'm connecting Check Point management. This is the Check Point management console, and how I'm connecting it into vCenter. So this is, here I'm going to put the username and the password for the vCenter in order to create a trust between the Check Point management and vCenter. You have many vCenters, you can connect to as many as you want. So I'm putting the name of my vCenter. This is one-time thing that I'm doing. Putting the username and the password, the IP address to connect to the vCenter. And now, checking the connection, I see that the Check Point management and vCenter trust each other. Now I'm creating my first rule in Check Point. So I'm going to add a new rule in Check Point. And instead of using a local object in Check Point, I'm going to import objects from vCenter. So what you see right now, these are in real time. I'm bringing all the objects from vCenter. I can search them, I can navigate them, and I can, with one click, add this object to my policy. So now I have these two virtual machines in my policy. And I can go and every change that will happen to those virtual machines, if the application owner will change the IP address, we add a new VNIC, we change the name, everything that will happen to this application, to these virtual machines, we will automatically get notified about it, and we will dynamically update the policy on all the gateways, the virtual gateways, the appliances, those that runs on-premise and those that runs in the cloud. Same level of integrations we have with NS6. So if you have an SDN, and NS6 is one of the most popular SDN technologies in the market by VMware, then now you can do the same level of policy, dynamic policy, based on NS6 groups. One click, and here I can see all the NS6 security groups from VMware, and I can add them to my policy. So now I added the objects from NS6, right? So I showed you how I'm doing it in the private cloud. You can ask yourself, okay, so how does it work in the public cloud? Same way. I will go to Azure, and I will show you that in Azure, it works just the same way, okay? Here, I can show you that I connect, first of all, I'm creating a trust between Checkpoint Management and Azure. So here you can see that I can create with Cisco APIC, AWS, Azure, NS6, OpenStack, and vCenter. We already created this trust with Azure. It's the same user credential that I did with vCenter. I'm doing it with Azure. Here, we already did it up front. I can show you later on if you want. With AWS, it looks the same. And now I'm bringing in real time all the objects from vCenter. And now I can use objects that I'm bringing in real time in vCenter in the checkpoint policy. I can search, I can find the object that I want, and I can add it to my policy. And the thing is that I can add in the source, I can add an object for vCenter from Azure, and in the destination, for example, I can add an object from AWS or for vCenter or NS6 or whatever I want. And as I mentioned, on both sides, it's fully dynamic, and you manage it centrally for all the objects from all the clouds. vSEC, in 2017, we have more than 4,000 customers that use vSEC to secure the different clouds. I want to share with you some success stories that we have with those customers. So just to give you a clue, we have a lot of the customers came from the finance. They are heavily using private clouds, but many of them using also public clouds. The retailers are using a lot of the public clouds technology, as well as governments. We see a lot of governments using the public cloud, and critical infrastructure we see using hybrid solution, a lot of private cloud as well as public cloud. So we see customers from all the different sectors using the cloud. Here's an example a little bit from finance and insurance companies. This is a very large global insurance company from Switzerland. They have a very dynamic and virtualized data center on premise. They decided to go with NS6 for microsegmentation, and they use Checkpoint to secure the traffic for east-west, as well as to provide a single security for all the north-south and east-west traffic. And what they like about vSEC with the integration to NS6 is the ability to automate things and the seamless integration they have. Also, since Checkpoint, when we look at NSS reports as a third-party vendors that evaluate different security vendors, we have the highest catch rates in the market against known vulnerabilities and unknown vulnerabilities. So they really appreciate that as well and decide to go with Checkpoint. And they already bought and expand their environments over for the third time. If we look at the public cloud, we see a large accounting service company. They are based in New Zealand, but most of the customers are from the US. They have over 1 million accounts that are deployed on AWS, a huge environment. They use hundreds of Checkpoint vSEC gateways to secure this environment with automations. We have a lot of big DevOps teams that are developing these solutions on top of AWS. and the ability, again, to integrate smoothly into AWS environment with auto-scaling and a dynamic policy is something that allowed them to move really fast and enable their application owners to make changes without feeling that the security slowed them down. If I'm looking at the government sectors, we have a state secretary in the US. They felt like they had actually an attack inside their data center, and they felt like they need to prevent lateral movement of malwares inside the data center. They also understand that patching servers, Apaches, and Linux and Windows, it doesn't take, it's not happening immediately, it takes time. So they were looking for a virtual patching technology. They, by the way, hesitated between going with host-based or network-based. They realized that network-based will be much easier to control and manage. And they took Checkpoint and deployed inside the environment with NSX integration. And they used Checkpoint to secure the east-west traffic as well as the north-south traffic. They also appreciate the fact that Checkpoint vSEC with NSX provides the best performance because we leverage the multi-threading technology that VMware gave us with NSX. So that's as well. This is a very large, a huge deployment in Azure by a legal department in the US. And they are holding very sensitive data in the cloud. And the main requirement was we want to make sure that no one will be able to hack into our systems. The data that we store in these environments can go into court. It's very sensitive. So that was the first decision to go with Checkpoint. Then again, the integration with this environment that needs to really scale up fast and needs to be able to duplicate itself into multiple locations was a key decision factor for them. So we've seen different type of deployment in private cloud and public cloud, different public cloud by different customers. And I want to leave some time for Q&A for you guys to ask me questions, and I'll be happy to show you more if you ask me the questions. So with that, I would like to open the Q&A. So I will read the question, I will answer them on the fly. Is there a way to dynamically add new vSphere VMs to existing rule without having to do a full policy push? Yes, the answer is yes. Once you are integrating into vCenter, you don't need to do a policy push anymore for changes that happens on the vCenter side. The VM will be pushed one time to the gateways, but then changes that will happen on this VM or in the NSX group or on the Azure object or whatever, doesn't matter wherever we get the object, you don't need to do policy push. It's automatically get updated across all the environments. I'm curious about on-prem Microsoft Service support for Hyper-V, host, and cluster, System Center, Virtual Machines Manager, Azure Stack. So first of all, we have Checkpoint vSEC running on Hyper-V. We support all the different type of hypervisor, including Hyper-V. And we also have integration with Azure Stack. So one can use Checkpoint vSEC with Hyper-V and with Azure Stack, just like they use it with Azure Cloud today. Please tell us about the plans with GCP. So we have Checkpoint running in vSEC, vSEC running in GCP. We have customers using the vSEC to secure the Google Cloud. All the capability that I showed in Azure and AWS are currently working in Google. We have auto-scaling. We have integration with the Google controller. We have the Google controller. Keep in mind that what I showed you before from the dynamic level, it's a capability that is part of Checkpoint R80. And in R80, we have a component that is called the vSEC controller, but it comes for free. It's part of the R80 management. And within the vSEC controller, we have a lot of plugins. These are predefined or pre-developed plugins for you that we have one plugin for VMware, vCenter, NSX, Cisco ACI, OpenStack, Nuage, Google, Azure, and AWS. Is NSX still a requirement in the VMware environment for vSEC to be operated? No. NSX give a great value if you want to have east-west security with auto service insertions. You can use vSEC on ESX without NSX at the virtual gateway, but then to secure traffic between virtual machines for east-west, it means that you need to explicitly redirect the traffic to checkpoint via layer 3. So the NSX give you auto service insertions and auto deployment of vSEC in the environment, and customers that are building their new data center or are relying on having on-prem data center for years to come, definitely they should consider using SDN technology, whether it's NSX or ACI. Again, a question, does vSEC works with Hyper-V? I answered it before. Yes, it does work with Hyper-V. Any plans for DigitalOcean Cloud? Currently, no, there is nothing that I can talk about this. Any other questions that you guys have? I want to show you just how the connection with AWS works. I showed you with Azure, but I didn't show you how I connect to Azure. So here I will show you how I'm doing it with AWS. So first of all, you need to understand that from the checkpoint management, you will be able to manage all the vSEC gateways across the clouds. So here you can see that I'm managing from the checkpoint RAT the gateway that runs on AWS. Just like another gateway that runs on-prem, here it runs on AWS. And you can see the utilization and everything and the version that it runs, and you can manage it directly from here, even though it runs on AWS. And as I showed you before, how I connect to vCenter, here I'm showing you how I'm connecting to AWS with the vSEC controller. So I'm putting the name of the AWS, and you can see that I can use access key, and I can select the AWS regions that I want to connect to. And then once I'm connecting to the AWS, again, it works the same way with any other cloud or virtual environment. By the way, you can also use IAM roles to connect to your AWS. But now I can go and I can bring into Checkpoint. You see, this is the Checkpoint GUI that I'm bringing all the AWS object into Checkpoint. And I can navigate through the object. I can use security groups. I can use VPCs. I can use virtual machines in the Checkpoint policy. All those objects, I can use them in the Checkpoint policy, and just selecting and navigating in one click, and I'm adding them to the policy. You can see also that when I'm adding an object into the policy, into the checkpoint policy, just a second. If I mouse over the object, you will see that this object came from AWS, and I can go and find all the metadata about this object that I brought from AWS, the IP addresses and a lot of information that I'm bringing from AWS into the checkpoint management console. Another question, can you show screens how everything's rolled up into a centralized location, please? Recommendation for notification, pro support. So I don't have a screenshot right now, a video that shows how I'm bringing objects from AWS, from Azure, for vCenter into one policy, but be assured that it's just opening the picker and selecting the object from wherever cloud that you want and putting into the policy, and then it just works dynamically across all the clouds. Any other question?
I think those are all the questions.
How did you import objects from VMware? So we import objects from VMware in two ways. I showed you how we import objects from vCenter. So we create a trust between the checkpoint management and vCenter, and you can connect to many vCenters. And this is how we bring the object from vCenter into checkpoint, and then you just, one click, you add these vCenter objects into the checkpoint policy. And you can, by the way, if you use checkpoint today and you have appliances, you can do it with your appliances. You can go and connect the checkpoint management, if you use R80, to your vCenter and start bringing objects and using them in your policy. Does vSEC perform quarantine in the cloud like it does in NS6? No, the only quarantine solution that we have right now is with NS6. I think we are coming with one also with Cisco ACI. In the cloud, we are not doing quarantine because we don't have a full SDN solution in the cloud, but we do prevent traffic when we detect it. So it's not a detection mechanism, it's prevention mechanism. We do have, by the way, in the public cloud, a very interesting integration with several solutions like Bracket, like Cloud Passage, like Guardicore, which gives you the ability to provide security on the host level and have a visibility across all the traffic with tight integration to checkpoints. So you can look for more integration between those vendors and checkpoints. Do you have plans to integrate with new Cisco DNA center? There's a discussion around this right now, yes, but there's no timeline for this. We do have, by the way, integration with TrustSec. So you can use TrustSec objects in checkpoint as well, Cisco TrustSec objects. Does vSEC secure AD or SharePoint? Yes, you can, if you use vSEC in front of any type of application like Active Directory or SharePoint or SAP or Oracle, whatever, it will secure it. So we have all the security functions that will allow you to secure it, and customers are using it all the time. Okay, I think we don't have any other questions. So thank you very much, everyone, for joining this webinar. And if you have more questions and you want to learn more about vSEC, you're welcome to visit our website. And you can also connect our vSEC overlay sales team that we have all over the world that will be happy to come and help you out with your cloud journey.
Great. So guys, we will also have this webinar replay available as well as the slides. So please look for that email shortly. Thank you everyone for joining the webinar. I hope you found it informative and useful, and we hope to see you guys in future webinars. Thank you again, and I hope you have a great day.